All right, so today we're going to be talking about inheritance. Again, we've teased about this. We've actually been using it with our unit tests and maybe a few other places, but now let's actually take a deeper dive into inheritance, make sure we understand what it is and kind of all the capabilities of it and why we use it. All right, so inheritance is one of the four main features of object-oriented programming. So these four terms hopefully aren't new to you guys. We mentioned them a couple days ago. So inheritance is going to be the focus of this presentation. Polymorphism, as I mentioned, is not as easy to see in Python because Python is a dynamic language, meaning you write your code and we have the Python interpreter kind of reads your code and uses it during runtime. This is different than other languages like C++, where all your errors and all your checks will be done during compile time. So you have a lot fewer runtime errors in C++ because a lot of your logical checks are done by the compiler. Versus Python, there's no real compiler. It's just when you're running your code, it goes line by line. If it runs into an error, and then that'll be done again during runtime. So polymorphism, again, is the idea that you can have objects that take multiple shapes. So if you want to just kind of talk about that in Python, let's create a new file. Let's just say hello.py. So one example of polymorphism is, again, this is kind of natural to Python. So other languages, it's a little more clear. But if I create a function, let's say my function, for lack of a better name, that takes in some object. Let's call that object something. It's going to be very generic with my naming here. Let's say all this does is print out something dot name. All right, so this something can be whatever, but I'm calling a dot name on it. Let's create a couple of classes. So let's just say human, and that'll just be this def init. I wish this one autofill. So self and name. All right, nothing fancy going on here. We just have a human class, and I'm going to also create a dog class since we've been talking about dogs earlier. Same thing. Again, these can take in various parameters. Let's say fur color, and person can have, I don't know, what's interesting about people. Let's just say height. Self.height equals height.
Eye color.
Yeah, I mean, yeah, I just want to kind of distinguish between, I guess dogs have height also, so I want to make something that's special to humans. I kind of failed at that. Let's just say social security number. I don't think dogs get social security numbers, so we'll make that a human only thing. All right, fur color will be fur color. Again, just to kind of mention again, the value that you create on instance does not have to match what your input value is. So, this can just be color instead of fur color. These names don't have to match. Usually you do want them to match, again, when you're using quarks or dictionaries kind of initialize values, just makes it a little easier to go back and forth. But yeah, this is totally valid. All right, so we have two classes. We have human and dog. The whole point of this was I could create a human object. So let's say I'll create a human object to reflect myself. Name would be Encore. And you guys want my actual social security number? Tough luck. We'll go with 888. Hopefully this isn't one of yours. If it is, apologies. So that's my social security number. Then we have a dog. Let's say, let's go with Lassie equals dog. Lassie, and I think Lassie's blonde. Is that right? Is it? I don't know. I'm not too familiar with Lassie actually. All right, so we have two objects we created. One is a human object. One is a dog object. With Python, you can pass in anything here so long as that has a name parameter. In this case, both my objects, although unrelated, again, my human class has no association with my dog class and vice versa. They're completely independent objects, but I could do, I say, let's call this print name to make it more friendly, print name. We'll print my name. And then last name, so print last. All right, so this is going to work because both of these have name parameters. In other languages, like C++ especially, you had to define what type this is. So you wouldn't naturally be able to say, all right, just pass in a dog or a human. Again, C++, different language, so I'm not going to talk too much about it. But in Python, this totally worked because when we get to this point, dynamically, it's going to say, okay, I'm at line 2. Does something have a dot name? It's not going to check that ahead of time. So if we actually did something like print name donut, so let's say we had a donut class, it would actually fail. So if I had donut here, I don't know, just go flavor. I guess donuts can have a name when you see them on the menu, but in this case, my donut class does not offer a name. So if I do something like this, and I create, say, lunch equals donuts, and the flavor will be lemon. Okay, so let me run this, and let's see what happens. So if I do Python, hello. All right, so we got Anchor printed out, we got Lassie printed out. I guess I should have capitalized Lassie's name, sorry Lassie. And then we got an error. So donut is not defined, that's, oops, lunch.
So could you have a name for the class that would be used to return something other than error for the other subclasses there?
Sorry, could you repeat that question?
Yeah, if you establish a name, I'm always trying to scroll up on your screen and it doesn't work at all. If you had a name in your overall class.
What do you mean by overall class?
What do you have on the first line of this file?
Okay, this function.
Okay, so we don't have. Okay, so each of these is an individual class that isn't part of a parent class?
Correct. Yep. Yeah. So as we get into talking about inheritance, we'll talk about how you can relate classes together. But in this case, my human class, dog class, and donut class are totally independent. There's no relationship between them. The key thing here is that's okay with Python. Again, this is kind of highlighting polymorphism. Basically, so long as whatever object I pass it can take the form of having a dot name attribute, this is going to be okay. So that's, again, polymorphism in play in terms of the something doesn't matter. The only thing that matters is that whatever we pass it has a dot name parameter, and then this object can, kind of fit to the requirements of this line. But yeah, there's no relationship between human, dog, and donut in this case. So again, that was just a quick example of polymorphism. So we also have abstraction and encapsulation. We've talked about these concepts before, so hopefully they're kind of making sense. Again, abstraction is the idea that we're removing complexity from the caller, and it's all packaged into our black box or our object that we're creating. So again, the complexity, the implementation is kind of hidden away, and all the caller or the user of your class should care about is that what the inputs are and that the outputs that it gets are correct. Again, everything else is kind of packaged into our classes or objects that we're creating. Encapsulation, again, in Python, not the best example or best language for it, but encapsulation is this idea of exposing methods and data members as needed, but kind of hiding away methods and other data members that don't need to be exposed. Again, in Python, everything is public, meaning once you create something in your class, anyone can kind of access it. Other languages implement that a little differently. But again, we don't want to focus too much on these three because today's topic is inheritance. So let's actually ask that question. What is inheritance? So again, just in everyday speak, not in coding speak. Does anyone have an idea of what inheritance is?
Something that's just passed along.
Yep, that's simple enough. So common concept of inheritance is like you might have grandparents that unfortunately they will pass away at some point. They might pass down like monetary inheritance or their possessions we inherited by family members when they pass away. Or inheritance can be thought of in a biological sense, like you inherit traits from your parents and your grandparents, and that's kind of passed down. So I think again, inheritance just in a everyday speak, I think we generally should have a good understanding that it's just something that's passed down from, I guess, a parent to a child, in that sense. So the good thing is, in a programming sense, inheritance basically means the same thing. It's the same concept as in with like the real world definition of inheritance. So what is inheritance in object-oriented programming? Inheritance is a mechanism where properties, so when we say properties, we're talking about, again, the two components of classes are attributes, which are data members, and methods, which are functions that act upon the data members that are passed down to derived classes automatically. And so just another way to say it, derived classes inherit, that's that magic word that we're focused on today, properties from base classes. All right, so you will hear various terminology. So I'm not sure if I generally stick to one, but I usually refer to them as derived classes and base classes. But you also will hear child classes and parent classes. So it's the same thing, just different terminology for inheritance. Any questions on the definition of inheritance or what it's kind of getting at here? All right, so again, inheritance is a mechanism that's used in OOP. Why do we want to use inheritance? So again, it's good to know what inheritance is, but it's better to know why do we care about it. So one is to create relationships between classes. So the example that I just did earlier with where we had human, dog, and donuts, they had no relationship with each other. And that's okay if that's what your needs are. But usually you do want to create relationships. Like, in a biological sense, dogs and humans have some relationship. Like we're both from the animal class, right? So if you remember that tree from biology, like you have all those kingdoms, right? There's animal, plant, fungi. There's two other ones that I always forget about. But dogs and humans have a closer relationship than humans and plants, right? So you can create these relationships to kind of model that. One key benefit of inheritance is that it reduces repeated code. So we've talked about the DRY principle, again, DRY, don't repeat yourself. There are some fun acronyms for the other case, or the opposite of DRY, which is WET. I've seen, again, there's no one definition, but for WET, one thing I've seen is we enjoy typing, which is, again, means like if you're repeating yourself, you're gonna be typing a lot more. So if your code isn't dry, it can be wet. Usually we try to make our code be dry. So increased reusability of code. Again, we create one component and that should be reusable across our application. We shouldn't have to write the same thing twice ever if we're doing our design and coding correctly. So inheritance kind of just gives us that functionality if done correctly. And then inheritance also lets us make changes a lot more easily. So instead of going, like, let's say we have a 10,000 line application and we need to make a change. Ideally, we shouldn't have to go through all 10,000 lines and say, okay, well, I'm using this variable here. Let me change that. Using that same variable, 20 lines down, let me change that. You could do a find and replace. Sure, that could make it a little easier. But the goal here should be you should have a single central place for your logic so that, again, if I need to change the number of legs that dogs have, like we talked about, if we go to Mars and find that all dogs have 5 legs, I should be able to adapt that in my code really quickly rather than kind of going through my code and saying, all right, I'm using legs equals 4 here. Let me change that to 5 in all places. Okay, so this makes your code, again, easier to adapt and modify. If we go back to the boggle example that we just did, remember that I implemented a length class attribute that was equal to 4. So the default case was 4, but since I had that, I was able to pass it a custom length, and my code worked just the same as it did before with, providing a 4x4 board or a 6x6 board, or theoretically I could do like a 17x17 board if I wanted. But again, that was inheritance in place, sort of, where I could have, I guess that wasn't quite inheritance, but I could have that extensibility present. Okay, so those are some reasons why we want to use inheritance. How do we use inheritance in Python? So we've kind of seen this, so this might be a review, but we generally create a base class, and then we create a derived class that uses a syntax. So in parentheses, we pass it the base class we want to derive from. So the base class, notice, has no parentheses. That's okay, because this base class is not inheriting from anything. So those parentheses are optional. If we wanted to add parentheses here that had nothing in it, that's totally fine. So it's kind of left up to what you want to do. I usually just leave them off if I'm not inheriting from anything. But my derived class is inheriting from something, so it includes these parentheses in the class definition, and in the class declaration, and it's taking in the base class that it's deriving from. just to review other terminology, again, we could use parent class and child class for terminology. They mean the same exact thing. So, don't be confused if you hear parent child class or base class derived class. You also might hear superclass and subclass. Again, these are all just synonyms, just different ways. People have preferences. I prefer derived and base class. I don't know why. That's my preference. I don't like super and subclass. Usually child and parent class I sometimes use, but they all mean the same thing. Okay, so we went over what inheritance is, why do we care about inheritance, and how we implement it in Python. Pretty simple syntax. Again, create classes, pass in base classes in parentheses. Let's get into types of inheritance models. So there are 4 main types of inheritance models that you will see, and then you can combine these in any way you see fit. So the first we have is single inheritance. This is the simplest case. So we have a base class and we have a derived class. All right, so if you want to actually just see an example of this, let's quickly do that. So I'm going to clear my code window here. So let's create a base class of dog, and dog will, let's just say, create an init method, self, and name. Simple enough. Self.name equals name. Let's create a more specialized dog class. So let's say class dog, whatever, let's do def speak for our base class, and we'll just say print wolf. All right, let's have a talking dog class that takes in, let's get with this, don't care about the name right now. Let's say this dog class can also speak, but this will take in an init and all right, so we have an instance attribute. So the speak method will actually say something that's not wolf. So in this case, we'll just print out self.word. All right, so we have a talking dog class and a dog class. So these are not related right now, but I want to inherit from my dog class. Right now, it doesn't make sense because I guess, there's no reusability here. Like we have our speak class that has nothing to do with our base dog class. But if we actually want to tie this together, we could do something like, let's see, let's create our init method again. Sorry, give me one moment. Had a caravan of children passing by a window. There's a school nearby me. All right, so init method, I'm going to do self, and I'll take a nothing. Let's do self.word equals wolf. Okay, so this is my design here. Sorry, I changed a little bit. So I have my dog method, which defaults to wolf. The word is going to be wolf all the time, and then self.word. So all dogs that I create, their only output for speak is going to be wolf. So there's just a generic dog. And then if I want to have a talking dog, where I can control what the talking dog says, I'm updating my word, as in I'm offering the caller of this to pass in a word value, but my speak method is going to be the same. So this is where inheritance is useful, where my speak method is going to be used by my talking dog class because it's inheriting everything that the dog class offers. That's what inheritance is kind of doing, and we talked about passing down properties. So this dog class that we're inheriting from is passing down all this functionality. We have access to the init method and the speak method. In this case, we define our own init method, so we're kind of ignoring, or the technical term is overwriting the init method from the dog class. And we're implementing our own. So now, we create a dog. So let's say Lassie is a regular dog. And then we could have Scooby is a dog that says, or talking dog, that says Scooby, Dooby, Doo. We have enough O's there. Okay, so now we have 2 dogs again, in talking dog class, only thing we're specifying is customizing the word, but the speak method is being inherited. So we can do something like lassie.speak. That's totally fine. That makes sense because Lassie's a dog and we have a speak instance method. But Scooby.speak is also valid because everything the dog class has to offer is offered in the talking dog class, and then we get add on to it as needed. So if we ran this, bring up my terminal here to Python hello, just to verify that this runs. All right, notice we get woof from Lassie speaking on line 16, but when Scooby speaks on line 17, we get Scooby-Dooby-Doo, because the talking dog class lets us customize the output for what that dog says. All right, so this is the simplest case of inheritance, where we have a base class, which is dog in this case, and then we have a derived class, which is talking dog. All right, so that's our simplest kind of inheritance. Is there a question?
Yeah, in the dog class, if you had self.legs equals 4, our other dogs would also have 4 legs, right?
Yep, you got it. Yep. So anything that the dog class offers will be accessible by our talking dog. So yep, if we create self.legs in our init method for a dog, that's guaranteed. I guess, sorry, it's not going to be guaranteed. So this is where I want to catch myself here. So if we did this now, there would be a problem. So we do print Lassie, Lassie legs, and then we try to do Scooby.legs. There is going to be a problem here. So let's run this and see what happens. All right, so we got an error. It says talking dog object has no attribute legs. Why did that happen? Answer is because we defined our own init method and we're ignoring the init method for our base class. So again, the init method always gets called when you create an object, but that doesn't mean every init method that exists in your chain will get called unless you manually call it. So this is kind of jumping ahead of ourselves, but we do want to usually call our base functionality unless we explicitly know that we want to avoid it. So that's where we use this magic super word and then call init like so. And so now this is going to actually call our base class, and then we're going to do whatever else we want to do after it. So we do this now. This init method, again, will be invoked so that legs will get created here, and then legs should exist for Scooby, because Scooby does have legs. All right, so notice we got our leg output now. So great lesson, or great question there. It kind of teaches a lesson. Just because we have implementation doesn't mean that implementation is being executed. We need to actually still call the base class if we're overwriting. Again, we're going to be talking about all these concepts going forward, so don't worry if I'm confusing you at this point. But okay, so simplest.
Sorry, can I ask a question real quick?
Go for it.
So you're saying that if we're going to call just to clarify, so you're saying if we call the subclass, it's going to kind of override the base class. It's not going to necessarily call it directly because Correct. We're calling the subclass instead of, did I understand that correctly?
If talking dog didn't have a def in it, then it would just have dogs in it and you could do other stuff with it, but they would not be in the init method. The reason they have to do that super is because both have an init method and you're extending it a bit in your subclass.
Yep. Jack has correct. So if I just had a talking dog class that had a pass in it, meaning there's no implementation, then yes, this init would be the default init that gets invoked. So again, it always kind of just goes up the tree. So it'll look in my talking dog class and say, hey, do you have an init method that you want to use? Nope. Then it's going to go up here. If we didn't have one here, then it's like, fine, there's a default init method that gets, kind of magically created that does nothing. But in this case, yeah, since we do have functionality here, again, the key here, I guess, is that we have the same name method. So again, Python's not going to just say, okay, you're calling an init, let me call both of them for you. It's going to call one specific one, and then you have to manually call the other one if you need it. And we'll talk about when you need to do that and why you should be doing that in most cases. But yeah, let's not get too ahead of ourselves. Let's kind of focus on our models right now. So again, simplest case is base class. Well, base class and derived class. Single inheritance. So we have dog and talking dog. That's our base class of dog, derived class of talking dog. Kind of extending this one more step, or as many steps as you want to, you could have multi-level inheritance. So you can have one base class, then a derived class, and then a further derived class. So technically speaking, in this case, class B here is both a derived class and a base class for class C, right? So A is a base class for B, B is a base class for C. I guess technically A and B are both base classes for C. But again, you could have as long of a chain as you want. If you want to have a chain of 20 different classes that are inheriting from one from another, that's totally fine, so long as it makes sense. I don't think you just do that just for fun. But again, this chain can go infinitely long as long as you need it, as long as it makes sense for your design. So in this case, like we might have a dog class, we might have a talking dog class. If we want to extend that talking dog class to be like a talking French dog class. So any words that the dog says is French. I don't know, that's not a great example, but basically the thing I want to point out here is what I have here on the right side. Your base class should be your most generic form of the class. As you go down this tree, you should get more and more specific. So, you know, your base class would just be a generic dog. Your derived class might be just like a smarter dog. And then your class C might be your smartest dog ever. Again, if you want to just kind of imagine how this is being from more generic to more specific. All right, so again, multi-level inheritance isn't too much more complicated. It's just basically a single inheritance repeated over and over as long as you need it. Any questions on that?
Now each of these levels can have an init, and how would I decide what I'm doing?
So let's kind of just add a new class here. So let's do class, I said French talking dog. Again, my naming, I'm using my naming just to be kind of consistent. You can name it whatever you want. You don't have to follow any naming convention per se. In this case, French talking dog will inherit from talking dog. So what's going to go on here is that talking dog will get everything that dog has to offer plus any other benefit. So let's just, you know, in this case, we have the option to override the word. Let's just say that French talking dog is going to override the speak method. And nope, sorry, VS Code is kind of auto inserting stuff for me when I don't want to. So speak is going to return, how do I want to do this? So this is printing something, so we're going to keep printing. Self.convert to French. All right, so I'm not going to actually implement this convert to French function, but you guys can imagine like might be some dictionary, some large dictionary that could take English words and convert it to French, for example. I guess I could do a silly example if you guys are fine with that. So let's have a class level attribute. Let's call that conversion. And that's just going to be a simple dictionary. If we have wolf, what's the French equivalent of wolf? Anyone have an idea? Let's just say
Oui.
Oui. I like it. The French dogs say oui. If you guys have never been to France, you guys will be surprised. And then let's say if they say hello, that'd be bonjour. I'm not sure what the Scooby equivalent is, so let's just say if we don't find anything, then we say. All right. So now that we have a French talking dog, we could do print. Oh, sorry, we're doing that already. So convert to French would take in, let's say, return if self.word in self.conversion, return self.word conversion. Again, let me know if I'm typing too quickly or if you guys are kind of lost. Basically, I have this class level attribute, which is just a conversion dictionary. I'm calling self.conversion because, again, technically I could have an instance attribute of conversion, but in this case, it's going to default to the class level attribute since I don't have an instance level conversion attribute. I'm basically checking if that word exists in our dictionary, return the French equivalent. Otherwise, let's just return the English or whatever the original word was.
I don't think self.word is defined here, though, is it?
Pardon? So self.word, again, is being inherited. So the key difference here is we don't have an init method. So when we create a French talking dog, let me get rid of my terminal to get more space. When we create a French talking dog object, we don't have an init method here. So it's going to default to the most recent init method in the chain. So again, going back to our example, A in this case is dog, B is talking dog, and C is French talking dog. So C does not have an init method, so it's going to go up one level and ask, hey, base class, do you have an init method? If base class does, we're going to use it. If it doesn't, it's going to go up one more level, and then it'll use the init method from our dog class. In this case, we do have an init method in talking dog. We don't have one in French talking dog, so this is for sure going to get invoked.
So we're also going to go back up and get the legs too.
Yep, since we're manually calling our init method on line 12 in talking dog, yep, this is going to happen. So basically, French talking dog will still have legs defined. It'll still have a word defined from talking dog, and then what else? Yep. Okay. So let's.
If French talking dog had an init method and used super, then would it just go up one level?
Yep. We'll cover this shortly, but yeah, the answer to that is yes. We'll talk more about super. We kind of introduced this here ahead of the game, but yep, if you call super, it'll go up one level, and then if this doesn't exist, it'll kind of jump up as many levels as it needs to. Okay, so that's an example of multi-level inheritance. Just again, another extension of single inheritance. Next type we're going to talk about is multiple inheritance. So multiple inheritance is the idea where you have multiple base classes. So in this case, we have A1, A2, A3 as 3 base classes, and B is deriving from all 3. This, again, is totally valid. Can anyone think of a quick example where multiple inheritance is kind of used in the real world?
Well, you have more than one parent, so
You got it.
you inherit 2.
Yep, Sean got it. That's probably the default example I always go to. So like, again, you wouldn't necessarily have 3 parents, but you would have 2 parents. So you would have A1 and A2, and you would be inheriting B. If I were, class B, I'd be inheriting some things from my father and some traits from my mother. So again, biology kind of gets more complex, but you guys can kind of easily imagine, like, eye color might be a dominant trait, I think. There might be some recessive traits. I don't know how you'd model that accurately, but yep, that's a good example where you have 2 parents, you're inheriting both, like, traits from both of them, and then somehow those are combined into the traits that you have. So multiple inheritance, the way we implement that, if I want to continue this example, get rid of my objects. So we have French talking dog, and dog. What if I wanted to instead create a class called French converter? No, that's not what I want to go with. How can I do this? So we have talking dog, something else I could put in here. So sorry, I'm kind of blanking out a good example to throw in here. But yeah, again, to kind of implement that, so let's just say we have another class called class.
Do like dog mom, dog dad, I guess, just to kind of
Some sort of service dog or something, a characteristic like that.
Yeah, I like that. So service dog. Thank you for those examples. So I'll go with service dog here, and then service dog would have some properties. I'm not sure right now what we want to go with, but in this case, we could do service dog has, let's say service dogs have certification.
So Ankur, I have a quick question. I noticed when you did your init method, it auto completed to self, and then it had an arrow to the none. What is that? Because I keep on.
Good question. That is syntactic sugar, I'll say. So if I can quickly get that out. Yeah, so you might see syntax like this. This arrow, none, is just kind of a hint telling you that this function will return none. So right now, I don't have any return value. So like for my speak method, that's not a good example. For my convert to French method, I could have str. So it's going to be telling anyone using this function that this is returning a string. So it's optional. You don't need to specify this. But again,
and it doesn't parse, like when you run it, it's just excluded, it's like commented out, or?
Yeah, I don't think it actually matters. So let's say I return an int instead. Let's say I return 5. Like this is an integer. I don't think it's going to care. So let's create a talking dog, because I don't think I've created one. Or French talking dog. So just say Remy equals French talking dog. Again, I don't have any init method, but so the word's going to default to wolf. That's fine. French talking dog, let's do remy.speak, and let's see what happens. Pop up my terminal, we'll do Python hello. Missing, okay, I see. So word equals wolf. Sorry, I'm not designing this the most elegant way. Probably should have an init method on my French talking dog. Okay. What did I screw up now? Line 33, speak, print. Line 33, converts. Takes
I
one.
think you need to have that as the keyword in against the object.
Gotcha.
Maybe.
Don't need to pass in this, sorry. So I have access self.word here, so I don't need to pass that in. That was my fault. Something I talked about earlier and I kind of screwed up. All right, so we got wee out here. Notice I'm returning 5. The whole point of this was you can return anything you want. This is just kind of a hint for developers. So if I handed this code off to John, John would know, okay, this function is expected to return string. So when he's coding this up, like when he's using the convert to French function, he'll see it in his like tooltip or IntelliSense that, hey, this is a method that is expected to return a string. So he can just know. Because it's not, again, in Python, there's no types defined. In C++, you actually had to tell the compiler what type you're returning from the function. But in Python, that's not true. You can return multiple types. But yeah, just to answer that question. Good question. We've not talked about that before. Okay, so again, init methods return none usually, so that's why that defaults none. All right, certification level can be intricate example. So service dog takes in nothing. We have dog. Okay, we can make this a little more complicated. I hopefully don't lose. So it's service dog is still a type of dog. So let's not get beyond that point. So dog is our base class. We actually have service dog and talking dog. But let's say we want to create a class of service talking dog. In this case, we're going to have multiple inheritance. Again, it's going to get a little dicey. Please stick with me. In this case, we want service dog as one of our base classes because that's going to have a certification level. But we also want talking dog. So in this case, we're going to inherit everything that talking dog has to offer us and everything service dog has to offer us. So sorry, limited space here. But yeah, so we create service talking dog. We just put a pass in here. Basically what this is saying is there's no extra implementation, but this is actually combining both service dog and talking dog into one class so that I could use that as one thing. So if I wanted to implement this or create an object, let me get rid of French talking dog or push that down. In this case, let's say I want to create a service talking dog. So let's call him hero equals service talking dog. So init method, there's no init method here. So the question is, which of these two init methods are going to get called, right? I have init method here, init method here. We're going to go over that, but the short answer is it's going to be this one. So this init method is not actually going to get called, so we probably should call super here. Again, we're going to go more in detail here, so kind of jumping ahead of myself, but service dog has a certification level of, let's just say, excellent. I don't know the actual certification types for dogs. They probably don't have levels, but all right, so here it's going to get excellent, and this init method will get called. Yep, okay. So again, it's a little confusing what I set up here. We have a diamond pattern, so dog is a base class for both service dog and talking dog, and both those kind of get aggregated into here. So when we call super init here, what actually is going to happen is this init method is going to get invoked, which is going to be kind of surprising because super init you would think just goes up to the base class, but that's not actually the whole story. So again, kind of getting ahead of myself here, but if I ran this and did hero.speak, that should work because we have our speak method here. Let's just say service dogs can speak. So let's just say times. All right, bring up my terminal. Do a Python. Okay, so we got an output of I'm smart because we're passing it to our next init method. Again, a little confusing what's going on here. This init method from super is actually calling this init method. And this init method takes in a word parameter, which is this. So we're not using wolf as our default, we're using I'm smart. And that's being passed to this init method. So this init method will call another call to super, and then we'll also store the word here. So this is a case of multiple inheritance where we're getting the functionality from service dog, which is a certification. I guess we're not actually using it, but this dog has a certification of excellent. So we want to do print hero.certification level. That will do what we want. Let's get rid of Remy. Sorry, Remy, gotta go away. So we run this. Notice we get I'm smart and excellent. So certification level is coming from service dog. Speak is coming from base dog. And I'm smart is from talking dog because that allows us to control that. All right, so that's the case of multiple inheritance. Again, you could have as many base classes as you want. You're not limited to like 2 or 3. You could have infinite base classes as long as it makes sense for your design. I'll make sure you're understanding what you're designing and make sure you're not kind of going crazy with base classes if you don't need them all. The next type we have is hierarchical inheritance. I always have trouble saying that word, but basically it's kind of the opposite of multiple inheritance. It's where you have one base class and you could have multiple derived classes. All right, so a simple way to continue our dog class here. Let me push down what we had before. You know, we can have different types of dogs, right? We could have class poodle, and poodles can have various functionality. Again, poodles, I'm not sure what's unique about them, but you know, you could have poodle, you could have I don't know what are those, German Shepherd. These dogs have different function or different attributes than poodles. I can't list off the top of my head. I'm not a dog expert, but you know, I think we all can agree that German Shepherds and poodles do have some distinct qualities. So in that case, poodle will implement whatever's unique to poodles versus German Shepherds would have what's unique to them, but they both are still dogs. So they will still inherit all of these attributes. So all of them are still gonna have 4 legs by default. All of them will still say wolf, but let's say your poodles instead of saying wolf, they say rough. So poodles can kind of implement that if they want to, and German Shepherd can inherit what they want from dogs. So we could have as many, again, base class or derived classes we want. So German Shepherd, poodle, pointer is the type of dog. So you have that. But yeah, I think you guys get the idea. You could have as many base derived classes as you want from one base class. That's totally fine also. Questions?
That would use the super as well, right? That concept to go
Yep.
up one level.
Yep, super. I'll always want to use super. We'll talk about super for sure. So yeah, if you guys have those, we'll talk about those.
This might be a little too far out into the weeds, but is there a good way to know, like in the design phase, when you're going to be wanting to use like a base, like to multiple child classes, or the opposite? Is there like certain types of problems that seems more appropriate? Is that like a future thing we're going to cover, or is this a good time to talk about it now?
No, it's a great time to talk about it. I don't have a great answer for you though. I'm just going to say it comes down to what your application, what your design is calling for. So you know, single inheritance just makes sense where you have, you know, just one, I guess, yeah, again, it's not a very great answer. It's gonna be reiterating what I've said before, but yeah, single inheritance makes sense where you want to just extend existing functionality and specialize a bit more. That goes true with multiple level inheritance. The more and more specialized you want to get, you would have this sort of design. This sort of design comes into play where you want to combine multiple functionalities. So with our service talking dog, again, since we need multiple concepts kind of combined into one, that's where we would use multiple inheritance. So proper design, you're gonna, again, when we talk about, you know, being a good software developer, your general goals are to break everything down to smaller chunks. So again, instead of just having one gigantic class that's doing everything for you, you want to try to extract functionality out of it so that it becomes reusable. Again, that's the whole point of inheritance. We talked about why inheritance. Reusability is one of the core functionalities of it. So if I go back to the examples that I kind of created here, now that I have service dog and talking dog, you know, I could reuse service dog without having to, you know, use talking dog with it, right? So instead of just creating one class like right here, so you guys kind of just imagine this, instead of combining all this with all this into one class like right away, I separated those out into 2 separate classes. So now that if I want to create just like another class that's like class French service dog. This would take in service dog. So in this case, I don't care about the talking part, but I care about the service dog part. So, you know, kind of going a little further, I probably want to create a base like French class or like a French dog class. Kind of getting complicated here, but basically reusability is the name of the game here. So I have French talking dog here. Since I'm creating a French service dog, that's where I'd go back to my redesigning and say, okay, well, I'm going to be using like this conversion logic again outside of just French talking dog. So maybe I want to make a class French base dog class. And this would have my conversion logic and convert to French method. Is that kind of making sense? I know I'm not really, I'm kind of jumping all over the place here with all these classes, but again, create just modular units so that you can reuse them as needed. If you create a gigantic unit, like if I just create a dog class and had all of this stuff nested in my dog class where I had, you know, the French conversion, the certification level, the ability to control what word the dog says, I could theoretically have that just in my dog class. The problem with that is sometimes all that functionality is going to be wasted because I don't need that level of granularity. If I just want a dog that has 4 legs and says wolf, well, at that point I have all this extra complexity in my dog class. Again, if I took this, and took all this and put it into my dog class, it would work. Again, it would work. That's fine, but it's not the best design because at that point you don't have something that's, you know, like Legos where you have individual pieces you can put together. You just have one big block that you had to use all the time. So yeah, Jack, great question. I don't have a great answer for it. It just comes down to what your application needs to do. So if you need multiple base classes where you're trying to combine a bunch of individual units into something that's reusable, so you'd create a derived class. You know, if you find yourself doing something often enough, again, like let's say you're creating a French talking dog repeatedly, well, you're going to create one object for it, so you could have that factory that prints out French talking dogs rather than kind of having to piece them together each time. Likewise, for this model, this is where you just have relationships where you have more specialized class that all relate to one class. So, you know, go back to biology, like you might have your animal kingdom, and then inside your animal kingdom, you might have mammals and then amphibians and arachnids or whatever the classifications are. So all those derive from the animal kingdom, because they're all are animals, but each have a special functionality. All right, so that's where hierarchical inheritance would work. There is like one more type of inheritance model. It's not really anything new. It's just a combination of everything we just talked about. So we talked about single inheritance, multi-level inheritance, multiple inheritance, and hierarchical inheritance. So the last type is called hybrid inheritance. So also you call it combinational. I just call it as much chaos as you want. So in the real world, your models can get really, really complicated. So I just have a random mockup here. This isn't anything that I've really made sensible. But again, you could have multiple base classes, and then within your application, you might have an example of hierarchical. So in this case, A1 is deriving down to B1, B2, B3, B4. Again, you have C1 is a case of multiple inheritance. Again, you guys can kind of see this diagram. Again, it's not, don't really try to pay attention to what's going on. Just understand you can combine all these inheritance models as much as you want. Notice that A3 is kind of jumping down 2 levels. So you don't have to necessarily just go, you know, level by level. You can kind of do something like this where C3 is deriving from B4, B4 derives from A2, but A3 kind of just directly goes down to C3. Again, the main thing when you're designing your classes is your base classes should be more generic, and then your derived classes should be more specific.
So with the
Also,
hybrid combination and the way you have the drawing, would it make sense to make your folder structure this way? So A1 through A3 would be at the top, and then B1 through B4 would be the next folder substructure, and then C's would be in the next, and then D would be in its last folder. So that way, when you're looking at it from a file perspective, you can see, oh, this is what you've described.
That's a great question. I've not actually thought about what the folder structure would look like for this. If you want to kind of break out your folders into base classes and then have nested folders, that, you know, I think that sounds like a good idea actually to me. So what John was kind of suggesting, if I were creating this model, maybe create something called classes, and inside classes I might have like A. So everything in A would be my like really, really generic classes, and then within A, maybe have a B folder. Is that what you're suggesting, or were you saying the B should be out here? I'm not sure. Again, I would say there's nothing I can say.
Yes, that's what I'm suggesting.
That's the best way to do it. But you know, again, always good to have good file organization. So yeah, if you have your A classes and all your Bs derived from As, maybe that's the way to do it. Or maybe you just nest it this way. I'm not sure. I've not really thought about that. So I'm just going to kind of say up to you guys how you think it's best organized.
That brings up the question, would a naming convention suggest what level the classes were at?
No. Usually no. So again, these are very, very generic names. You're not going to be naming your classes A1, B2, whatever. So this is just for my example. Normally, it's going to be more like what we're doing with our dog. So you have dog, you might kind of append words to it, but in this case, poodle is just a type of dog. I don't really have poodle dog. But if I wanted to be more consistent, maybe I could, have that in my name so to make it more clear what poodle dog is. It's a dog. It's a class that derives from dog. But no, your naming just to be sensible from like a developer perspective. I wouldn't say you should always kind of just keep like, I have service talking dog. Like this name's kind of getting long. So like the next class I have is like class French service talking dog. Again, these names kind of get silly. I'm not saying this is the way you should do it. So maybe I might just have instead of French talking dog, first French service talking dog, I might have something like special dog, whatever. Just keep it less wordy, I guess. But nope, usually you won't be naming stuff based on the level they're on.
And actually, it may not be clear what level they're on until you're pretty much done inserting levels and creating dependencies. Right.
Yeah, so for the most part, levels don't really matter, but they do in like certain cases. So in this case, A3, you could actually put like A3 down here, right? You can just make this B5, for example. Because in this case, yeah, it doesn't matter that A3 is all the way up here. Like A3, if there's an arrow here, the level would matter. So maybe that's something I should have done. Imagine there's an arrow from A3 to B4. Well, at that point, A has to be on this level. And it's going to make sense as we talk more. But with that, I want to go through maybe another example, if you guys don't mind. And then we'll take a short break. So let me trash this. Let's create a new file here. I'm going to call it shapes.py. And then in shapes, I'm going to create a class called shape. And that's going to be my base class. And I'm going to create a class called square. Pass that. These are not going to really have functionality right now. Let's say circle. Here's from shape. So it's square. Should probably type circle correctly. And then let's add one more shape, just for good measure. So class triangle. All right, quick quiz for anyone that wants to answer. What type of inheritance have I set up here?
You've done the, what is it called?
Multiple inheritance.
Was it multiple?
Yeah, you have the single parent, multiple children. It's the not multi-inheritance, but hierarchical.
Yeah, that one, yeah.
Yep. Yeah, again, names are hard to memorize, but kind of understand the concepts. But yeah, this is a hierarchical example. All right, so I'm going to do one thing here. I'm going to give some functionality. Let's just say print, or no, let's go with area. So sorry, this should be a function. So I need my def keyword. Always remember yourself for instance attributes. So area for a square is going to be self.length times self.length. And this means I am going to need to create a length. So let's do that quickly. Self.length, be length. Okay, simple enough. For circle, similar, but we have radius instead of length. So let's just go with radius, and radius. Area for a circle, I should probably return something. Return, back to geometry class, it is self.pi times self.radius squared. Going back to math class, there's an order operations here. So right now it's not super clear what's going on. Are we going to multiply this first? Are we going to do the exponent first? There's an order, so exponents happen before multiplication, but I always like to be clear. So I'm going to put this in parentheses just to make that super clear. We need self.pi to be created. Let's see. And then we do triangle. I think triangle does something like, again, geometry's been a while for me, but init, and then self, and then we have a base and a height for triangles. Sorry, these stop. Okay, and then this would be self dot base equal base. Sorry for all the geometry review. Just want to code this up quickly. Height, and then area, if we remember correctly, I believe is return self dot base times self dot height times 0.5. So you take half that. All right. Can anyone comment on anything I've done here? Anything that they would want to change?
Can you move area to a different class since you're repeating yourself?
That's a good thought. So I definitely could move area down to perhaps shape, but the issue is, I mean, I can have that, but there's two concerns here. One is that shape in itself, if you just think about conceptually what a shape is a kind of an abstract concept. You can't really just compute an area of a shape. I guess you can, all shapes do have an area, so that's true. So we can have an area here, but I don't know how to compute the area of a shape, just a generic shape, right? So square, circle, and triangle are more defined shapes, and they have defined areas. But yeah, we could have a base method that just does nothing or returns, return, I don't know, 0, return none. That's not actually valid. Again, shapes do have an area, so returning none will be good. But yeah, it's a good thought. There's something else that I do want to. There's something wrong with my design here. I will say that.
Shouldn't you separate the types of shape classes, like have a separate file for circle, triangle, and so on?
Yep, Stephen is absolutely correct. You should be doing that. I generally don't during lectures just to save time, but yes, we should definitely be creating separate classes. So I could do that as we kind of think about this. So kind of look at this. There's still something wrong here that I would like for someone to point out. So I'm going to create some quick classes here. Wrong design-wise. This is functionally, this is totally correct.
You are repeating yourself with that area.
What do you mean by that?
Within each class, you are repeating yourself.
Yes, so I am repeating myself, but in this case, I have to, because each of these shapes, the area is computed in a different way. There's no way that I know of where I can combine, length times length, and also map that to pi times radius squared. Also this, so it is repeated, but it is necessary to repeat this area because each of these shapes compute their area in a different way. But no, I like the way you guys are thinking. Definitely don't want to be repeating ourselves if we don't need to. Any other thoughts before I kind of give you guys the answer? Sorry, let me keep that code up here. Shapes. Gosh. All right. Maybe start out a little bit more. Again, it's not obvious, so don't feel bad if you're kind of confused.
Can we scroll up to the top as well? Okay.
Okay, so this is something I started typing before, but then I purposely did it differently. Self.pi. Can someone comment on that?
How precise you want to be with it, I guess.
Precision, yeah. That we could definitely add more. Does anyone have those digits memorized? Is it 1, 6?
1.14,
1.9,
358.
All right, yeah. So we can make this more precise. That's definitely a valid suggestion. So we'll go with that. Any more comments on self.pi?
You have it in caps as a constant.
Yeah, it's a constant, so you don't need it as a self. You can make it as like a shape variable.
Absolutely. Yep.
I can just import the math.
That's it. I think, yeah, Steven suggested there's probably a math.pi, which is totally correct. I guess, yeah, what I was going for is I think what Steven said. In this case, pi is a constant value. It's not dependent on each implementation of circle, right? So each circle object I create, they also have the same value of pi. So Steven is correct. This doesn't quite make sense as an instance attribute. It should be a class level attribute because again, pi is always the same for a circle. Again, theoretically, pi can be reused with like other shapes like ovals or whatever. So maybe I don't want pi nested in circle necessarily, but in this case, it's a class level attribute because all circles use the same value of pi. So yep, good catch there. So again, just going back to our discussion of class attributes versus instance attributes, make sure you guys understand when and why those exist and when to create those. So I was creating these files. I'm not sure if I want to actually go through with it. But yes, whoever made the comment of you should be putting separate classes and separate files, totally valid. Again, for lectures, I kind of do it the quicker way. So apologies there. Okay, cool. We have these shapes here. I'm going to create another shape here. Let's call it class rectangle. That's gonna be deriving from square, and then rectangle is gonna be a little different than square. So we have init, length, and let's just say height is another part of the rectangle. So we have super init. It's actually curious that VS Code was smart enough to add the super for me. I was not expecting that. We'll do self.height, height equals height. All right, so we're gonna call super. Again, super is gonna call our base class. In this case, it's square. It's gonna call this init method. So length will be set to the length value.
Seems like you're upside down, and that square would be a derivative of rectangle.
Height, and then we'll do area. Yeah, Don, good point there. Area will be, in this case, self dot length times self dot height. All right, Don, you actually nailed it on the head. Could you repeat what you said?
Square is actually a derivative of a rectangle because it inherits all the characteristics of a rectangle, and the sides and lengths just happen to be different, the same.
Yep, Don actually, yep, caught it. I was trying to throw you guys off. My question was going to be, why is this incorrect design-wise? So technically, this is going to work. So again, it goes back to the concept of you do things multiple ways, but design-wise, if I get circle out of the picture, I have 3 classes here. I'm using multi-level inheritance. We go back to our models. So I'm using a case of this where I have a base class of shape. In my current design, I have my derived class as square, and then my further derived class is rectangle. Why this isn't the best design is kind of what Don was saying. Rectangle, a square is a type of rectangle. All rectangles are not squares. So while this will work in the way that I've designed, so like length and height, like since I have my own area defined here, this will work. If I create a rectangle, the area will be computed correctly. If I have a square, area of square will be computed correctly. The problem here is that goes back to what I was talking about, generic and specialized. So my most generic class is shape, which is, again, that's correct because shape is the most generic idea here. But square is a specialized form of rectangle. Rectangle isn't a specialized form of square. So the way I have it right now, yep, it's technically design-wise improper, although it would work. So Don caught it right away, which is great to see. So this should derive from shape, and then square should derive from rectangle. Before I change that, I do want to make sure we talk about this. So some of you guys might be thinking, or a thought I've had is, well, let's actually think about square. So square only has a length parameter, right? Versus rectangle has two values. It has a height and a length. So one comment that might be valid, you might say, well, actually, if you think about it, rectangle is creating more data, right? Because you're storing 2 values. So why not have square, which is, a simple form? Again, it has less data. Why shouldn't that be your intermediate class? Because again, if you switch these, if I have rectangle and then shape here, so that the ordering is in this way. If I switch these, now anytime I create a square, I'm technically going to be creating this height that I'm never going to use. So I could pass it length. Actually, I need to pass it length. So in this case, I have extra data. So although that isn't the most efficient, this is still the proper way to do it, because actually I can inherit my area function now, because length times height is going to be exactly what I want it to be in this case. Sorry, that should not be length here. Length should be part of my super call. Does that make sense? Why swapping these is the proper way to do it?
Oh, question.
Again, the whole idea that we're reflecting here is that your classes at each level should get more and more specialized. So shape is super generic. I think we all agree with that. Rectangle is a specialized type of shape. Again, it has 4 right angles. It has even, parallel sides. That's what a rectangle is. I guess you could have another intermediate class. I believe it's like rhombus. Is that the shape? that has parallel sides, but not necessarily all right angles. So you could throw in another intermediate class here if you needed to. Rhombus, not rhombus. How do you spell it? I think it's rhombus like that. Anyway, enough geometry recap. But rectangle is a specialized type of shape. A square is a specialized type of rectangle. So you're getting more and more specific the further down the chain you go. So that's why this ordering of classes is more proper than what I had before. Both would work, but this is arguably more correct.
So why is the super init? Why does it have two lengths?
So super init. So now that my square class is inheriting from my rectangle class, I'm calling my init method with length and length. The reason I'm passing that is because rectangles take, I guess I need, that's my goof. So this needs to take in a length now. So rectangle takes in two values, length and height. So let's say I'm creating a rectangle. Let's actually create some objects for our amusement. So let's create a rectangle. That's gonna be a rectangle, and this will be, let's just say it's a 4x6 rectangle, all right? And then we can also create a square. SQ equals square. And a square only has one length, right? Because they all have the same sides. So in this case, let's make a square that's 7. Let's make it 5. Put it in between. All right, so square only takes in one value because all the lengths are the same. So we pass it one value. But since a square is a type of rectangle, rectangles need a length and a height. So for a square's example, the length and the height are the same. So we just pass it length and length. Like it's mapped to length and height. Rectangles take in a height and length. And the area for both of them is length times height in this case. So we're reusing this area method. So that was a suggestion that was made before. Like, you know, we don't necessarily need all separate areas if we can combine them into one function. So for square and rectangle, their computation is the same. It's length times height. For square, length and height are equal. So if we want to, you know, do that, we could do area. The question, again, super init, this is just calling the base class. So for square, rectangle is the direct base class. So super will automatically figure out, hey, you're calling rectangle, let me call init for you. Did that answer your question?
I also have a question.
Yeah.
Oh, sorry.
Yep.
In that square class, could you use a quark in that init as well?
Quark.
Or that super, I'm sorry, in the square. This at the bottom where you're calling length and length.
Yep, right here.
Could you use a quark within that as well?
You can, yeah, but in this case, the ordering doesn't matter, right? Because it's just length and length. But yeah, if you want to, you could totally use quarks here. That's fine. Print SQ area. But yeah, in this case, you don't need them because again, the ordering of the parameters don't matter. Like whichever way you put length, it's still going to be length. But that should work. All right, let's give this a run. Make sure everything runs. So clear this. Let me make this a little larger. We're running Python shapes.py. All right, so area for that rectangle is 6x4. We get 24, right? Hopefully everyone agrees with that. And then for area of our square, we just call square.area. Again, this is being inherited. So we're using the same area method from a rectangle. Now we're getting 25 because 5 times 5 is 25. I would agree with those computations. Any questions on designing classes? Again, the whole lesson or the part that I'm trying to get to is when you're designing your classes, go from more generic as your base classes. Every derived class should be more specialized. So make sure you don't flip those. Like again, square and rectangle, there's a proper ordering in like the geometry of everything. So your classes should reflect that ordering from super generic to specialized to even more specialized for your square.
I don't have a question, just a comment. This is easier than the algorithm stuff.
Easy again, yeah, easy is subjective. Again, for some people, algorithms might make more sense because I would argue for algorithms, it's mostly just, hey, you have a problem, go through your tool chest or your tool shed and use the tools you know, get from point A to B. For classes, it's, I think, again, not necessarily easier, it's a different mindset you're using. It's more creative because you're designing, you're a designer in this mode where you're like, okay, there's probably infinite ways I could arrange this class diagram here. Which one makes the most sense organization-wise? So I wouldn't say easier. I would say definitely a different type of mental challenge when you're designing classes versus trying to solve algorithms. I do think those are both unique traits. Both are important to kind of master as we're progressing along through our curriculum. Okay, with that said, I want to take a quick break. Hopefully you can wrap this up without eating too much into your lunchtime, but we do have a few more topics to get through. So let's take a quick break. So what time do I have here? I have 11:32. Let's take an 8-minute break. Please be back by 11:40, and let's try to power through the remaining parts of this presentation. All right, so we cover the types, different types of inheritance models you can have. So just to go over those quickly again, we have single inheritance, multi-level inheritance, multiple inheritance, and hierarchical inheritance. And then again, we can combine those into any forms as needed. Whatever our application design calls for should be possible. All right, so now we're going to be talking about some advanced inheritance topics. So kind of just to make sure we understand some terminology, some functionality with Python, and understand when inheritance makes sense and when it doesn't make sense. All right, so the first thing we want to go over is overwriting properties. So there's two terms here that I want to go over. There's overriding with a D, and there's overwriting with a T. So unfortunately, these words are very similar sounding. So I'm going to make sure I have to enunciate when I say both of them. But overriding is a concept where you create new attributes or new methods to kind of mask existing functionality. All right, so you're not actually replacing what's existing. You're kind of just covering it up or creating new functionality that supersedes the base functionality that you're overriding. So derived classes have the option to implement their own version of an attribute or a method, but they don't have to. So if a derived class overrides a method, it's going to basically create its own functionality, and the base class is going to keep its functionality as is. If you don't override anything, then it's going to default to what the base class is offering you for functionality. Overwriting, on the other hand, is actually replacing existing functionality with your own. So again, these are similar sounding names and they're both similar concepts, but there is a distinction, and we want to make sure that we understand the difference between overriding and overwriting. So let's obviously see an example. I think that'll hopefully make things clear. So let's create another file in my file trove. So let's just say over.py. So if I have a class, and let's just call it food. Food has def init. Class of donuts. We have init, and this would take in flavor. This takes in name. Okay, so I created two simple classes here. One is a food class, that is my base class, so that's what donut is going to inherit from. So I'm going to add that inheritance there. We'll use our super method, which we will talk about more. So there's still some confusion. Hopefully we'll alleviate that. All right, so we call our base class. We also want to store the flavor equals flavor. Okay, so in this case, donuts are derived class, food is our base class. So one example here of overriding is this init method. Our food class still has an init method. So if I create just a generic food item, let's just say f equals food, and that's going to be, I don't know, chips. And then I want to create donut. Donut's going to have, let's just say, lemon. Let's call it donut. And flavor will be lemon. I'm not sure if I've had a lemon donut. I guess I've had like a lemon poppy seed donut. Anyway, off the topic. So again, we have our init method in our food class, and we also have it in our donut class. The donut init method is overriding the base functionality. So they both exist, and we can call both. So food will call this init method, donut will call this init method. Okay, so it's an example of overriding.
And the donut class is overriding in line 6 because it has an extra attribute, which in this case is flavor, right?
Sorry, say that again.
So the donut class is overriding the init method because it has an extra attribute, in this case flavor, on line 6.
That's not the key differentiator. In this case, if I don't have flavor, it's still overriding it. So if I do something like this, this is still overriding it. And in this case, it's not doing anything extra, but this init method is overriding this init method, overriding with a D, because we've recreated a function with the same name that overrides this. The same thing can be done with class level attributes. So for example, if I want to do something like self dot yummy, say all food is yummy, or let's say all food is not yummy, you can create another, sorry, not a self, apologies there. You create another class level attribute with the same exact name. In this case, you are overriding this class attribute with this class attribute. So if I do something like, make this more accurate to my tastes, if I do something like print f dot yummy, and then I print d dot yummy. So again, this yummy is pointing to this. So this is overriding this value. The reason they're overriding is basically because they're using the same name, but the derived class is providing functionality for it. So this yummy is masking the yummy down here. So I run this, do a Python of over.py. Of course, I need to put flavor back. Flavor equals flavor. All right. Okay, so we got false for food.yummy, which is a Boolean. Maybe we should name it is yummy to be naming stuff correctly. So usually for Booleans, I prepend it with an is, so it's a yes or no. But yeah, so d.isYummy is using this value because that's overriding this value. The value in these classes, again, get preferential treatment for donut. So basically when I call isYummy, Python is going to check the donut class and see if donut class has anything by isYummy. I could also do something like self.isYummy and some value here. So I do this now. Again, this is kind of nonsensical, but I create an instance level attribute of isYummy. In this case, this will override this value. So if I did this now, false would get precedence because instance attributes get first preferential treatment, then class level attributes, and then base level class values get called. So there's an ordering there. It checks instance attribute, does it exist? If so, it'll use it. If it doesn't exist, it'll default to the class level attribute. If the class level attribute doesn't exist, it'll go to a base class and check there for a class level attribute.
So then I have a question based on what you just said. Should we start from the inside out, so the instance level in the init method, and then work our way out, or is that still a design choice when you're designing?
What do you mean by work your way out?
So you just said that self.isYummy takes precedence over the line 8 is yummy, and then it takes precedence over the class attribute too.
Yep.
So from a design perspective, would it make sense to start from the inside out, meaning, or it just depends on what you're doing?
Sorry, yeah, I'm not sure what you're asking about design perspective, start inside out. As in when you're creating these variables? Is that what you're asking?
Well, just in the general creation process. So line 13 takes precedence over line 8, as you just mentioned.
Yep.
And then line 8 would take precedence over a global variable, right?
Global variable, I mean, in this case, it'll take precedence over line 2.
Okay.
So if I did create an isYummy here, this is not tied to any instance. So this would be unrelated.
Okay.
Maybe we do something that's more, like, probably do like calories or something instead of doing a Boolean. So if I want to change this to calories instead of having a Boolean, maybe that would give us a little more granularity. So calories, let's say a default food has 2,000 calories. That's just made up. Donuts probably are a little more caloric. So let's say 500 calories. And then if a particular donut wants to specify like a different value, we can. But calories and calories. All right, so again, this is an example of overriding. So I've not really overwritten anything in terms of Food still has access to calories. That's not been modified by what donuts is doing. Donut just overrode it by creating the same named attribute or same named method. And in that case, these get preferential treatment over before these do. That's an example of overriding. Example of overwriting is basically replacing the value with something else. So in this case, if I do something like donut.calories equal, say 800, in this case, I'm overwriting this value. This value is actually changing, right? So I actually lose this 500. So that's what overwriting is. It's actually replacing functionality. You can do that with methods also. So let's say I had a method called def is yummy. Self, and then this will just return true. So in this case, I have a method called is yummy. I can overwrite it if I want to on the instance. So let's say I create 2 donuts. Let's get rid of food to declutter what we're dealing with. So we have donut 1 and we have donut 2. Donut, same name, just say donut 2, donut 1. Let's just say root beer as a flavor. I feel like that might not be delicious. So in this case, the default value from is yummy is true. Let's say I want to replace that. So for D1, we'll use the default is yummy. D2 can do something like lambda. Just go lambda return false. D2 dot is yummy. All right, so I'm actually replacing this function with a new function. And it's not liking what I've done here. Let me return value. Okay, so now I have a new function that returns false. Again, this is lambda syntax. I could do something as easy, but doing like is gross. Instead, if you want to make this a little more clear, this need to take in self. So is gross return false. So if I do this way, that should work. All right, so I'm replacing my is yummy function for D2 with an is gross function. So now is yummy no longer, this function no longer exists for D2, for donut 2. I'm overwriting it as in I'm replacing what exists with something new. This is different than overriding, where I could maybe create a mask for this if I created a new class. If I had like a gross donut class, if I want to quickly create that gross donut, this inherits from donut. In this case, I could create a def is yummy, and this would return false. So again, this is an example of overriding, because I create a new function with the same name. So gross donut overrides the default functionality of is yummy. Versus overwriting, the way I'm doing it now, I'm actually overwriting what existed before. So I'm replacing it entirely for that instance, because this is an instance attribute. So if I run this, yep, go for it.
So on line 12, sorry, this is like back a little bit.
That's fine.
When you so donut is immediately overriding the food init stuff.
Overriding with a D, yes.
Yeah, yes. So what is line 13 bringing? So like, is that providing functionality, or like is that connecting it somehow?
It's connecting it. So in this case, I'm still calling my base class so that name is assigned and created. But if I didn't want to do that, I totally could avoid it. So instead of doing this, I could do something like self.name equals donut plus name. Like let's say I just want to control the naming of it. So it's always donut plus name. So maybe I should create this.
Oh, I see. It was bringing the name attribute. Okay.
I don't know. I'm not naming these really well, but yeah, if I want to just like do my own thing for name, I can kind of ignore this completely. If I want to call it, I still have the option to call my base, because again, I haven't overridden it. It still exists entirely. So if I want this logic, I can call it from my init method here.
Okay, thank you.
Likewise, I still have access to food.calories. So, you know, I've overridden it again with a D here, but food.calories still exists. So if I want to do that, I could still print out, like, again, food.calories still exists for any purpose that I need it, if I want to call it directly. Okay, so again, overwriting versus overwriting. Again, similar concepts, similar sounding words. Just kind of understand that overwriting is just kind of masking something and creating new functionality on top of it. Overwriting is actually replacing the existing functionality with something brand new. So I didn't quite run this, but I had is yummy. In this case, donut 2 has that. So what went wrong here?
So can an instance overwrite something that's in the base class?
So it looks like I screwed this up. Is gross missing? I guess we gotta pass this. Have a lot more stuff left there. Okay, so again, is yummy, I replace it with is gross. So in that case, this is yummy no longer exists for donut 2. Don, sorry, you had a question? I missed it.
Can an instance overwrite something that's in the base class?
Can an instance overwrite something? So you're saying, can I overwrite like a function here? Good question. So if I have an is yummy here, return false. Let's get rid of this stuff. I don't know, let's keep that around. So I have this method. You're asking, can I overwrite this from my donut class?
Yes.
I'm kind of struggling to see how I would be able to do that, but also I would add, if I already have this functionality, there would be no reason to overwrite this that I could think of. I guess if you want your derived class to call
I'm wondering if there's something in the base class that doesn't really exist yet in my instance. Could I, if I overwrote it in the base class, it would mess it up for other instances, or change it, I should say.
No, it would not. Again, these are instance attributes. So I kind of highlighted that here. So donut 2 is replacing its instance attribute with is gross, but donut 1 is still using this is yummy. So again, these are instance attributes. So each instance you create, basically you're creating a copy of that function each time. It's the same thing as creating instance attributes. So when I create self.name, each individual donut has a name attribute, and each individual donut has an is yummy function. So in this case, I replaced one of those functions, one of those instances, I replaced the function with is gross, but my D1 is still using the base is yummy. So again, when I ran my code here, I got two different outputs. I got true from this output because is yummy from the instance is returning true, but this is yummy for donut 2 is using is gross because that's what I replaced. Is I overwrote with a T is yummy. All right, so again, overwriting, just kind of understand the distinction. You'll hear those terms. Make sure you kind of understand what's going on there. All right, next up, we have abstract base classes. This one I'm not going to talk too much about. I just want to introduce the idea. So abstract base classes, if we go back to our shape example, in this case, just to review, we had a shape class, we had rectangle, we had square. I think we had a couple more down here, circle, triangle. Right now, there's nothing that stops me from doing shape equals a shape instance. Again, we have our shape base class. The problem here is, or at least a problem that I could think of is, again, shape has there's no default way to calculate the area of a shape, like a generic shape. So right now I'm returning none. That doesn't really make sense. Like in my application right now, I don't want my users of my classes to be able to create a shape instance because shape is just a generic base class right now. There might be more useful functionality in here. Right now there isn't, but shape, again, I don't want to be able to create a shape because shape.area isn't really something that is valid, if that makes sense. So this is where the idea of abstract base classes comes into play. So let's say if we actually want to give this functionality, we could create a simple init with a name. So now all shapes will have a name. So we do self.name, just do that, and then I guess we gotta do some super calls here. That's not what I want. Rectangle. All right, this is gonna get messy again, so bear with me. Okay, so I probably want to pass a name throughout here instead of doing it the way I'm doing. So this should be name, and therefore this can be okay, so I introduced some value in our base shape class, so that has some functionality. In this case, all shapes will have a name, and that's going to be stored here. Area, again, is the issue here. Shapes, by default, there's no way to compute just an area based on the way I'm thinking of it. It's like square, rectangle, and all these shapes, they have a way to create area or compute area. Why is this circle all over the place here? Okay, so we have this functionality. Basically, what I'm trying to get at is I don't want to really be able to create a shape because a shape is a generic concept in my application. So this is where the idea of base classes come in, or abstract base classes come in. So if I clear this and run this quickly, I do Python shapes.py. Init method. This is from line 24, right here. All right, so this kind of highlights my issue also, like what name am I going to give my shape? I could just name it shape, but that's not really descriptive. Okay, so this runs print area. All right, the whole point here, the shape class isn't really usable. I don't want it to be usable. This is where abstract base classes come into play. So I'm going to add some code and then we'll talk about it. So I'm going to import from ABC. This is a module in Python. ABC from ABC. All right, so ABC stands for abstract base class. And there's a class called ABC. I'm going to inherit that here. And I'm going to add a decorator. What this is doing is not defined. Okay, what this is doing is now this class is going to require any class that you derive from it has to implement this area function. If it doesn't, you're going to get an error. So let's create a new shape quickly. Let's do class, I don't even know. Let's just say pentagon. I don't know the area formula for it, but we'll pretend I do. So this is a shape. And let's say I just create a pass here. So this is going to be a problem because this logic right here is saying anyone that derives from shape has to implement an area. This base class is not going to compute the area for you. And that is true because I have no idea how to generically calculate an area for any random shape. So now the way I have it designed is that shape is an abstract base class. It's deriving from ABC, which is the base abstract base class. And this abstract method is saying anyone that derives from shape must implement an area. All right, let's kind of give this a run. So if I try to create a shape object, let's see what happens. Notice I get an error. Can't initialize abstract base class with an abstract method area. That's again because this is saying you need to define an area. Area has not really been defined here. So if I try to create a pentagon, which I've created here, let's try to create a pentagon. Pentagon, name would be pentagon. Okay, I'm trying to create a pentagon shape. This is similar to if I'm just creating a square. So we've done this before. Square doesn't take in, it takes in a length, so 6. So if we give this a run, notice I still get an error here. It's actually not a runtime error. It's, I guess, compile time error. So this is saying, hey, you're trying to create a pentagon object, but you've not defined area function. Again, this is for design purposes. This makes sense in that if anyone's going to be creating a shape, they should be ready to define an area. That's just requirements I'm requiring for my application. So since this class is deriving from shape and I'm not defining an area, I get an error. And this is an error that I want to see because I want all my classes to define area. So I do area. Fortunately, I don't know how to compute area here. So if I just do return, so the area is 5, that's not true. Now that I've implemented this area function, I should be able to create a pentagon object. Obviously, I didn't print out anything, but it created this pentagon object. You could do stuff with it, like print p.name. All right, we get pentagon. All right, so again, I don't want to introduce too many new concepts, but the idea of abstract base class is to require functionality from a base class for derived classes. So derived classes kind of are, you can create whatever you want, but if you want to require that, hey, all classes must have an area function, that's the way you would do it. And this makes sense, again, from design perspective, requiring derived classes to have certain functionality so it's guaranteed to exist. This is the way you go about doing it. Okay, so that's abstract base classes. Again, the way to implement that, you got to import ABC, which stands for abstract base class. You got to derive a class from that, and then you can use this abstract base or abstract decorator to make a method required from derived classes. Okay, let's talk about method resolution order. Again, a lot of advanced concepts here. I'm just kind of introducing them. If you guys are still kind of confused by them, definitely can do a Google, or we can talk about it more probably at stand down. But MRO. So this is where there's some magic, or not magic, but there's some order to the chaos behind the scenes. So method resolution order determines how inherited properties are kind of prioritized. So let me quickly create a coding example so we could talk about this. Let's go mro.py. Let's create some really generic classes. Let's create class A1. That's going to be define a method, print something. Give me my method name, takes in the self, and we're just going to print A1. All right, that's class A1. Let's create a few more classes. So we'll have B1 inherits from A1. And we saw an example of this before, if you guys recall, where I'm creating a diamond problem. So B1, let's create B2, which inherits from B1 also. And then I'm going to create a new class called class C1. That's going to inherit, it's going to use multiple inheritance. So it's going to inherit from B1 and B2. All right, so this is called a diamond problem because you have A at the top, you have B1, B2, and then C kind of combines B1 and B2. Let's put this in here. All right, everyone kind of with me, what these classes are doing? I know I'm going sort of fast, but hopefully not confusing you guys. So we have 4 classes. A is our base class, B1 and B2 both derived from A1, and then C1 derives from both B1 and B2. If I give this a run and create an instance of C, so let's call that, let's call it C, and I do C that print something. Well, this is sort of an easy case because we've overrode any base functionality and defined our own print something function. So if I run this, hopefully you guys won't be too surprised that output is C1. Reason being is because we have a print something method here, and that prints C1. My question to you is, what if we did not define this? Now the question becomes, I'm calling print something, which exists in all these base classes. Which one actually is going to execute? It's not going to be all 3, right? When you call print something, it's not going to actually just say, all right, I found 3 occurrences in your inheritance history. I'm just going to call all 3. That's not how inheritance works. There's a precedence that is set, and this print something will call one of the 3 above. The question is, which of the 3? The answer here is it's going to call B1, but it's not clear why. But this is where the MRO comes into play. So if I actually run this, I would expect B1 to be printed out. Notice I got B1. That's not magic. It's not random. Like, it's not saying, all right, you calling print something, let me just grab a random print something and then we'll go with it. This is what the method resolution order is specifying, is how the priority is given if there's not a local attribute or local function to use. So in this case, C1 has not implemented a method for print something. So the MRO is going to go through the inheritance model and figure out what the ordering will be. So the precedence is given left to right and then upwards based on the derivation. So in this case, B1 is the first item that's inherited from. So if we actually swap the ordering here does matter. So if I put B2 before B1, B2 is going to get precedence in the case where there's a conflict. So in this case, the conflict is print something. First, we're going to search B2. So I'm calling print something on the C object. The first thing it's going to do is going to check in class C1, hey, is there a print something method, instance attribute or instant method? Answer is no, there's nothing here. So then the MRO is going to say, okay, where do I search next? The answer is you search the leftmost. In this case, it's B2. So it's going to go to B2 and say, hey, do you have a print something method implemented? In this case, the answer is yes. So our output was B. Sorry, I didn't run this again. In this case, our output is B2 because that is the first place we're checking after checking C1. But hypothetically, let's say I name this something differently. Let's say I name it X underscore print something. Now, this method is not what's being called. I'm calling print something. So if I run this, the answer should be B1 because in our inheritance search, C1 has nothing called print something. So we're done checking there. Then we go to B2. We check in B2. Is there a print something method in here? Nope, because we renamed it. So we're going to continue our search. Now it goes to B1. So it goes left to right in inheritance. So B1 gets called. And we check, hey, does B1 have something? Yep, we found print something. So we're going to actually execute this function. If hypothetically this was not implemented, well, next up in this ordering, even though it's not specified here, A1 is next in the inheritance model. Again, there's not an explicit A1 here, but that is fine. In the inheritance model, we have A1 at the very top level and then B1, B2. If B1 and B2 strike out, the MRO is automatically going to go to the next level up. So in this case, it's A1. So if I clear this and run this, notice we get A1. Final situation, which I assume you guys will know the answer to this. What if I rename all three? What's going to happen here?
Is it going to crash?
Yep, we're getting an error. So when I try to run this, it says, yep, C1 has no attribute print something because it searched every place that it knew where to search. It searched C1, didn't find anything. Searched B2, nope. B1, nope. And then finally goes up to A2, which is the last point of search because there's nothing else in this inheritance structure. So in that case, it's going to say, all right, you're trying to use something that doesn't exist. I didn't find it. What are you trying to do? All right, so that's the whole idea of the MRO. It's just there's a predefined way that Python is going to search for functionality. If your current class doesn't have it, it's going to search through the inheritance tree, but in a set order. It's not a random order. So again, the way you specify inheritance here does matter. So B1, B2, this means B1 gets priority over B2. A handy thing you could do in case, again, these models can get really complicated, you could call C underscore MRO. If I print that out, prints. So again, MRO is another dunder method or dunder attribute in this case. So if I run this, actually, no, sorry, that is a function. So MRO is a dunder method that's pre-baked into any class you create. So still failing here.
It was a
Class name, sorry. So you gotta do C1. So not on the instance, you wanna do it on the class itself. My apologies there. All right, so we get this output. It's not the easiest to read, but notice we get C1 first in our list, then we get B1, B2, and then A1. We also get this class object. We kind of ignore that, but this is the order of the MRO. C1 gets priority, then B1, B2, and then A1. If we swap this, we would expect that to be swapped also. We run this, notice C1 is still first, then we get B2, then B1, and then A1 is last in precedence. Questions about MRO? Anything I lost you guys with?
So I guess it's obvious, but why was it implemented? Did somebody put it in there because they were thinking ahead or because somebody messed up something like, oh, we have to fix this?
Why was what put in, sorry?
MRO.
MRO, again, it's to tell you that there's a predefined order so that as a developer, I know that there's a preset order that everything is going to go through. So in this case, if I have something coded like this, I know that B2 is going to be checked first, and that can matter for what I'm trying to do. Because again, if I have multiple functions, like if I have something like def print other self prints, let's just say that prints other B2. And I have B1 here. So in this case, if I do c dot print other, this will be fine. So print something is going to go to B1 first and check there. So B1 gets priority. So B1 should be printed out from this call in line 20. Print other, though, it's going to check in B1 and say, hey, there's no print other here. Then it's going to go to B2. So this can matter because if I have this swapped, in this case, print something's going to print B2, and then print other is still going to print other B2. So again, based on how you want your classes structured, that's why the MRO kind of exists. This is just an ordering that's predefined, just to give you as a developer understanding of how the precedence is going to be executed.
Also kind of helps you map out like organizationally how everything kind of relates to each other, right? Like how
Sorry,
these
what was the
things-
question there?
I'm sorry. So it's also useful to kind of help map out like how it relates to each other, each instance, right? Is what you're saying for us as a developer to have like that visual when we're printing that C1 MRO down there.
Yep, this MRO kind of, again, just helps you understand how your code's going to work. Okay, your code should never be random, as in it's not going to be random execution. There's a predefined order. MRO is giving that order, if that's the key takeaway. Again, understanding kind of the precedence. I do have a more complicated example. So I'll go back to my slides here. This is a simple example.
So, where it says C1 before the MRO, does it mean it's gonna try to run C1?
Yeah, so C1 is a class. So this is just telling you what the class MRO is for C1. So in this case, it's C1, B2, B1, and then A1 is the MRO for this class. So yeah, again, you got to call MRO on the class object, not the instance. That's something I confused earlier.
Yeah, but it's calling C1. There are other classes over there.
Yeah.
So
the class name is C1.
calling C1. Yeah, calling C1 is gonna means it's gonna execute C1 first, or it's gonna execute C1 last.
So C1 is my class. MRO is telling me the MRO for C1. I could do prints B1 MRO. Any class you create has a method resolution ordering. So B1 would be simply B1 gets checked first and then A1. So if I actually want to print this out, I can do that quickly. I know we're running into lunchtime, so we'll try to wrap this up in the next 10 minutes or so. A1. All right, so notice down here, we get B1 and A1. So each class has a predefined MRO. So we check MRO on the class, not the instance.
I understand. What I was asking is the order which the classes will be like executed. So what the MRO is saying down there by the C1 is that you should check like the C1 class and then follow the order.
Yep, you got it. Yep. So yep, in the case of C1, C1 always will be checked first. So when I call print something, we're always going to check here, does print something exist? And then you're right. Yeah. So B2 is listed next in the MRO. So that means B2 is going to be checked next for print something until we find something. Until we find what we're looking for, then we stop the search. So if we find it in B2, we're not going to continue on to B1 and say, hey, does print something exist? Because we stop here. So I do have a more complicated example, but in the interest of time, probably won't get to it. So simple example, we have two base classes, B1 and B2. C1, you go left to right. So in this case, the example here would be B1 and B2, and A1 doesn't exist. So we'll remove that. So this is the example I have coded here, and a diagram for it, again, is listed here. More complicated example, I'm not going to go over this unless you guys want me to, but this is a more complicated example. This is where the levels kind of come in play. We have A1, we have B1 and B2 both inherit from A1. We have C1, which inherits from A1 directly, but C1 also inherits from B1. Again, it's complicated order, probably hard to picture. And finally, we have D1. The MRO here kind of is hard to figure out, but you go left to right. So in this case, C1 would be your, D1 is where you search. C1 would be next in line. Then would be B1, then actually B2. A1 would still be last because it's the highest up in this ordering. You guys want me to code it up or should I move on?
I think I understand what you're trying to say.
Okay. If you guys want to see this,
Same here.
if you guys want to see this as stand down, I can code this up. But again, the MRO, it's not easy to kind of deduce. But again, the whole summary here is there's an ordering. It's a little hard to understand, but again, when we get into super, I guess that's probably. Let me just code this up. Actually, I apologize, because I do want to highlight this a little more. Okay, so we have A1, B1, B2. We have C1, which directly in this case inherits from A1. And I'm just trying to recreate this diagram. So A1, C1 also inherits from B1. So let's add that in there. A2 doesn't exist because that's an A1. This is a C1. And then we also have another D1. A lot of classes here. D1 inherits from C1 and B2. So C1 and B2. Let it pass, and let's create a D object and just list the MRO for this. So print D. All right, let's give this a quick run. Tuple, not callable. Okay, so I listed out the MRO for D1. Notice D1 always is first. Then we have C1, B1, A2, A1. Again, it's kind of hard to process from here. If we swapped B2 and C1, so now B2 is first. Let's see what the MRO looks like. So notice B2 jumps ahead of C1 in this case, because B2 is getting priority, and then C1 comes next, because that is next on the list. The reason I wanted to code this up is for our next topic of super. So we've used this super keyword. You might kind of have a question of why is it that important? Why does it exist? So it automatically calls the proper parent class, and I should probably strike this out and say not parent class, but proper class that's next in the MRO. So in a simple example where we have this, let's say I want to print out A1. So one way I could do this is call A1 directly and do print something. So in this case, I want to execute both this function and this function for B1. This works. You can call a method directly like this. It shouldn't be an issue. Let's do, actually, this will be an issue, sorry. We could do print something of, sorry, I'm a little confused here too. This won't work, will it? B equals B1. What do I want to do here? This won't work, will it? Nope. Yeah, so if I want to call A1, I do super. Okay, so that works. So again, super is going to know the proper, I guess, chain of MRO. So if, for example, we want to chain all of these, we could print, we could add these supers in here. So again, super doesn't always go to the parent class. In this case, A1 is the parent for B. But if we looked at the MRO here, so this MRO goes D1, B2, C1, B1, A1. So if I look at B2, when we call super here, super is not actually calling A1. That's the thing I want to highlight here. A1 is the parent class of B2, but super is going to look in the MRO and call print something on the next item up in the MRO. So if we look at the MRO, after B2, C1 is actually next up, not A1. So if I actually ran this, I would expect that I print out, let me get rid of the MRO here. I'm going to call d.print something. All right, so d.print something, the order will be D1. It's going to go to B2 and print out B2. So let's actually implement something here. Okay, so if I've done this correctly, again, super searches the next item in your MRO, not necessarily your parent class. So that's the key takeaway here. So I run this. So I get D1. So A1's at the top because I'm printing this first. Let's swap these orders. All right, so basically whoever gets called first will be on the top of the stack. Okay, so I run this. So notice D1 is first, B2 is second, C1 is still next. This is what the MRO should have guaranteed. So that's why super is important to use, as in super should not, you shouldn't hard code like what you want to call next. Super will do the work for you so that you don't have to figure out the MRO. Super just knows what the MRO is and will do the proper thing for you. Again, use the super instead of using the class name itself is to ensure proper MRO. If I had coded this better, I could highlight that better, but unfortunately I did not. But you can call the class name for class level attributes, but super would be the better way to do it. So if I had like a class level attribute here, word equals A1. So now in this case, if I printed out word, I'm not going to go through this example, but again, you can call class level attributes by using the name itself, but usually you should use super. All right, so super will just do the hard work for you. It'll know the method resolution order and call the appropriate item after what's in there. Okay, so last topic.
Super goes to the top of the hierarchy?
Nope, super goes to the next item in the MRO. So notice A1 was still last here.
That's what I thought, but why is that different than just not having that method there?
If you don't call super, it won't call the base class. So this won't print out anything after B1 is hit. So if I put that here, let's say I comment out on B2 and ran this code. Notice it stops at B2 because we're not printing out anything. We're not calling any other function here. So the super lets you continue onto base class if you want to. Again, this makes sense. This is case by case basis. You don't always need to call a base class. If in this case, I don't want to be printing out anything else, then I don't need to call a base class. It's optional. It's based on what you need to achieve. Again, these are generic.
So you're saying that if I don't have a method, it'll look at one level above me, and if they don't have it, we're done?
Nope. So great question. Let's comment out B1. So B1 no longer exists. So in this MRO, I believe it was B2, C1, and then B1. In this case, B1 does not have that method. A1 will still get printed out, assuming I add back my calls here. So if I do hit this, I screwed something up because I need functionality here. Okay, notice I got D1, B2, C1, A1. Even though B1 has no implementation and B1 is in the MRO, it basically checked B1, but super checked there and didn't find any B1, so it continues on in the MRO. So it checked here, didn't find anything, it continues on to A1. So again, super is smart enough to know where to find the methods it's looking for. So super does search in B1, doesn't find it, it's going to go to A1 after that.
I'm totally lost because I thought that's what happened if the method just wasn't there.
So if again, you need to call the base class yourself. So if I don't have this here, the base class again won't get called. I'm not sure if this addresses any of the confusion, but if I run this now, it stops at B2 because I'm not calling further down the chain.
So if we also did the same, like if we passed B2, then it would just revert all the way to A1 is what you're saying.
Yep. Yeah. So if I, didn't have this method here, didn't have this method here, didn't have this method in C, yep, it'd go all the way to A1. It'd search as long as it finds something, I'll execute that. If you want to continue the chain, you manually had to call super and the method that you want to continue to. And then super will continue looking on the MRO until it, until you get to an endpoint. All right. So again, super, just understand that you want to use super instead of calling the base class directly, because sometimes the MRO is not going to be aligned the way you expect it to be. So don't just kind of rely on calling the class name in certain cases where you could, but super is the proper item to call unless you have a specific reason why you want to avoid following the MRO. Usually you should not kind of circumvent the MRO. All right, promise is the last concept. We're going to be talking about inheritance versus composition. So before I let you guys read that slide, sorry, let me create a quick example and let's talk about it. So I'm creating dog.py, create a dog class. Let's implement a $string method. And this was to print out some values for us. So return f-string self.name and self.fur. Color. Okay, I'm going to create 2 more classes here. I'm going to call it class name. And this will be def init. This will take in first name and last name. Self.name. All right, so I'm creating a name class that's basically storing first and last name. Similarly, I'm going to create a fur class like such. Fur, and this was taken, let's say, color and length. So fur will have color, and it'll have a length. Okay, so we're creating these base classes that I'm going to inherit here, name and fur, and here. Okay, so dog has an str method. All right, so name comes first, so we'll take in color equals none, 1, and call super here. This is kind of messy, but let's go with it. All right, so I have 2 classes, name and fur. Dog is inheriting from both of them. Let me create a quick dog class or dog instance. So I'm going to do dog equals, let's say, Scooby, last name do. Fur color is orange, and I believe Scooby has short length hair. So we'll go with that. I think that's what I want to do, and then print out dog. Let's see if this works. So do Python dog.py. Dog isn't actually name. Gotcha. It's first and color. All right, so we got my name is Scooby, and I have orange fur. Everyone with me so far? Okay. Question is, this works. This worked as I want it to work. I got Scooby and I have orange fur. Why is this improper design? And again, this is something I don't expect you guys to know off the bat because that's what the whole point here is, but this works. So this goes back to the whole notion of you can get things to work, but that doesn't mean it's necessarily good design. Reason is the topic I was trying to highlight here, inheritance versus composition. So as we talked about before, OOP is a popular paradigm. That doesn't mean OOP is always the proper thing to use. Likewise, inheritance is a popular paradigm to use when you're creating classes. It is not always the correct choice. So when we talk about inheritance, we're talking about is-a relationships. So for example, a dog is an animal. So it's a type of animal. A dog, that means dog class should derive from a generic animal class or a base animal class. Likewise, a square is a type of shape or is a shape. So square should derive from shape. So these are the inheritance models we talked about. But there's also an idea of composition. These are has a relationship. So a dog has a name. It's not a is a relationship. So before we get too into the weeds, yes, you can probably mangle English in ways to say a dog is something that contains a name, whatever. You can probably convert it to is a sentence if you want to, but just keep it simple. A dog has a name. It's not something that is inheriting properties from a name. Does that make sense? Like a dog is not a type of name. So this is where you want to use composition, not inheritance. So has relationships, again, a dog has a name or a square has angles. The dog class should own a name class, not inherit from it. Okay, so I'm gonna highlight that. This is a bad example where we're using inheritance. It works for our needs, but it's improper design because a dog is not a type of name. A dog is not a type of fur. These are attributes of a dog. They're not, what a dog is, right? So the proper way to do this would be to kind of own these objects. So these classes are fine, but the way we're structuring this is incorrect. So if I do init here, there should be self. It should take in a name object and a fur object. So let's just say fur. Hopefully a name is fine enough. All right, and then we'll do self.name equals name and self.fur equals fur. Again, this is doing the same exact thing. We're just changing the way we're structuring this. So we're going to pass in a name object and a fur object. So this needs to change to name.first and fur.color. Okay, so now our initialization is a little different. We'll do name is Scooby. I wish I kept what I had before. Last name do. And then we're going to pass a fur object in here also. So the color would be orange and the fur length would be short. All right, so now we're passing objects in here and our dog is owning those objects because a dog has a name. Like, again, the name is a part of a dog. It is not, I don't know quite how to explain it, but yeah. So a dog is, again, has no direct relationship with name in terms of like name isn't like a base class of dog. A dog is something that contains a name. So conceptually, that class of dog should contain a name object, not derive from it. All right, so this is going to do the same thing. Our output's going to be exactly the same. If I've coded this correctly, of course not, because of this. Okay, I think that should take care of it. Nope, self.first. Sorry for my typos here, typing quickly. All right, third time's the charm. There we go. My name is Scooby and I have orange fur. Same output. Again, their structure is what I'm trying to highlight here. Is-a versus has-a. If it's an is-a relationship, use inheritance. So a dog is a type of animal. My dog class should derive from a base animal class if that one existed. Has-a, again, a dog has a name. So my dog class has a name class attribute, not deriving from name. Okay, so just understand inheritance is very powerful, but it's not always the right answer to achieve your design solutions. Okay, that was a lot, I know. I apologize for eating into your lunchtime, but key takeaways, know what inheritance is. So again, that's the idea of reducing redundant code, kind of having reusable components, passing down attributes and methods down to lower classes so they could reuse them if they want to, or they could override them if they need to. So our shape example, we have the area class. The area class needed to be overridden because each class computes its area differently. So kind of understand what inheritance offers. Know the different types of inheritance models. We talked about simple inheritance, multi-level, multiple, hierarchical, and then just understand you combine those into whatever chaotic class diagram that your application calls for. Just know how to use inheritance in Python. So we've gone over that a few times, but understand you pass it in parentheses at the class declaration. And the ordering does matter. Again, remember the MRO. So in this case, name would get precedence over fur, but this is a bad example. We shouldn't be, I should have actually removed this when I made my changes. So dog should not inherit from anything. It contains those objects. But if you want to use inheritance, we go back to shapes. Again, you would pass values here. If you want to have multiple inheritance, you totally can. So kind of understand how to do that. Final thing, know the difference between class inheritance and class composition. That's the last thing we went over. Inheritance is when you're trying to reflect is-a relationships. So a dog is an animal versus class composition. Those are has-a relationships. A dog has a name, a dog has a tail, a dog has legs. So those would be composed within the dog class. Okay, I know that was a long lecture. I apologize for taking up so much lunch. Before we depart, any questions on any of the topics we went over? Yeah, we will have stand down today. So if you guys are still kind of iffy on any of the concepts, we can go over them more in stand down. Yep, I'm seeing a lot of tired faces. I know, again, that's a lot to take in, understandably. Again, high level takeaways. Know what inheritance is, know how to implement it. Don't worry too much about the MRO or any of the more advanced topics necessarily. Just kind of understand when to use inheritance and how it benefits you as a developer. All right, just gonna catch my breath there. Last thing I wanna go over before we depart for a late lunch, today is the 3rd. Let's just go over the challenges for today.